Okay, this is the Pre-Algebra Unit 6 test review on percents. The first three questions are asking us to compare two different numbers, telling them whether they are less than, one is less than, equal to, or greater than the other. So the first question is to compare 14% and 0.145, or 145 thousandths. So what I'm going to do is I'm going to take this number right here, and I'm going to change that into a decimal by swooping my decimal twice to the left, so it's 0.14. So now I'm comparing 0.14 to 0.145. So 14 hundredths compared to 145 thousandths. And in that case, I could add that 0 here on this 14 hundredths to make it 140 thousandths. So they have the same decimal number. And 0.145 is definitely bigger than 0.140. So that is greater than 145 thousandths is greater than 14%. Or if you read it from left to right, 14% is less than 145 thousandths. So the next one, again, is comparing 67 hundredths to 66.6%. So 67 hundredths, as you write that as a decimal, would be 0.67. And 66.6%, when I change that into a decimal, you'd swoop that twice to the left, it would be 0.666. So we know by looking at the hundredths place that 0.67 or 67 hundredths is bigger. So in this case, our answer is greater than. 67 hundredths is greater than 66.6%. Now our third question is to order the numbers from the least to greatest. So that's the important part there, least to greatest, and we need to remember to write them in original form. So what I'm going to do first is change them all into the same form so I can compare my four numbers to tell me which one's the smallest, which one's the biggest, and put them in sequential order. So I'm going to change them all to decimals. I work better with decimals. You guys can choose to do whatever one you want. If you'd rather do percents, that's fine. So I'm going to change these all to decimals, and when I do that, I end up getting 3.39 is, I'm going to keep that the same. This is 0.44. This is 0.26 or 26 hundredths, and this 0.009 or 9 thousandths. Now when I'm comparing these four numbers, I find that 9 tenths of a percent is the smallest, so 0.9%. Second smallest is 26 hundredths. Third would be 39 hundredths, 0.39. And then last but not least is 44%. That is our greatest number. Now we're going into lovely word problems. So since we have word problems, our answer should be in sentence form. Our answer is a complete sentence. Hopefully we remember to do that. We're wrapping in math. So we're going to restate our question, answer it, and then our proof is our work. Okay, so our first word problem says 4 candidates participated in a school election. Melissa received 7/100ths of the votes. Chris received 36 hundredths of the votes, or 0.36, and Demetrius received 11%. So we want to find out how much Sherry received, because she received the rest of the votes. Now total, our vote should equal 100%, and we're finding what percent of votes did Sherry receive. So our answer should be in percent form. Now 7/100ths, when we write that as a decimal, is 0.07. That a little thinner. Our second one, 0.36, that's already in decimal form. And then 11%, if we change that 1, 2, would be 0.11 there. Now I'm going to add that up. So 7 plus 6 plus 1 is 14. Carry that 1. Or regroup, 3, 4, 5. Okay, so 0.54, 54 hundredths is the total amount of votes they've received, the other three, not Sherry, not including Sherry. So what I'm going to do is subtract 1 whole minus 5/4. Going to have to borrow here. So we end up getting 46 hundredths. Now we need to change that into a percent. So what we do is we're going to swoop once, twice. We end up getting 46%. Now our final answer, again, needs to be in complete sentences. So we would write Sherry received 46% of the votes. Now I want to make sure I answered my question. So I restated my question. It says, what percent of the votes did Sherry receive? Well, Sherry received 46% of the votes. I answered my question, and I proved it by this work right over here and right here. So I used my wrap in math. That's what wrap in math would look like there. Now again, for 5, we need to make sure we answer this in a complete sentence. So it says the minimum highway speed on Highway H is approximately 80% of the minimum speed on Grapefruit Way. Now, if the minimum speed on Highway H is 60 miles per hour, what's the minimum speed on Grapefruit Way? So I'm going to write out my equation, and then I'm going to round it to the nearest mile an hour if necessary. So I know that Highway H is approximately 80% of the minimum of Grapefruit Way. So our answer for Grapefruit Way, that miles per hour, should be larger than that 60% here. So it's 0.8 or 80%. I changed that into a decimal by swooping once, twice to the left. 0.8 or 8/10 H, and I'm just going to use H for highway, equals 60. So 80% of some number should equal 60, and that some number, that H there, stands for the minimum speed on Grapefruit Way. So I'm going to divide both sides by 0.8 or 8/10 to get H all by itself. And when I do that, when I divide 0.8 into 60, I'm going to swoop there, add a 0, bring up that decimal. When I divide that, I end up getting 75. So my H equals 75. Now I'm going to go back and make sure I answer my question completely. What is the minimum speed on Grapefruit Way? So my answer should restate that question. The minimum speed on Grapefruit Way is 75 miles per hour. And that is my final answer there. Now let's go on to number 6. 8 and 32 hundredths is 16% of what number? If necessary, round your answer to the nearest hundredth. So that's 2 decimal places. So what I'm going to do is set up a portion, which is, let's do 8.32 is my is. Now, of what number is what I'm trying to find? So my of would be n, equals 16 over 100, which is percent over 100. So I'm going to write that up in the corner just in case we need to remember that. Is over of equals percent over 100. So now I'm going to use my shoelace method, the cross products, and 832 equals 16n. Now I'm dividing both sides by 16 to get n all by itself. So those 16s cancel. When I divide 832 by 16, we put the 832 inside of our division house, we end up getting 52. So n equals 52. So our answer should say 8.32 is 16% of 52. So we made sure to answer our question. We restated our question, which is the R. 8 and 32 hundredths is 16% of what number? Well, we wrote 8 and 32 hundredths is 16% of 52. We answered our question, and we made sure to prove our answer with all this lovely work we have here with our cross products and division. Now we're going on to number 7, the second page of our review. The longest river in the United States is the Missouri River. It is 2,540 miles long, which is 134% of the length of the Rio Grande. Find the length of the Rio Grande to the nearest tenth. It's important there, so I'm going to box that. Now I know that the Missouri River is the longest river, so my answer for the length of the Rio Grande should be smaller than 2,540. So what I'm going to do is I'm going to set up my equation, 1.34. Now that 1.34 came from this lovely number right there. Change that into a decimal by swooping once, twice. So I get 1.34. 1.34n equals 2,540. So 134% or 1.34 times some number, some length, which would be the Rio Grande there, equals 2,540, which is the length of the Missouri River. So what I'm going to do is divide both sides by 1 and 34 hundredths. And when I divide those two, I end up getting approximation. I have to round here. So my n approximately equals 1,895.5 miles. I had to round that to the nearest tenth. Now, my final answer should be written again in a complete sentence, so I would write the Rio Grande is about 1,895.5 miles long. Now on to our next problem, number 8. Says a bank loans a customer $43,000 for a period of 15 months. The simple interest rate of the loan is 8.2%. What is the total amount that the customer will need to pay the bank over 15 months? Now there's a lot of information in here. We have to remember to write our equation, make sure we plug in our numbers in the right spots. So I'm going to first start out writing the formula. I equals PRT, or I per, like I told you guys. Now the bank loans the customer $43,000. So in that case, that is our P. So I don't know our I, that's what we're trying to find. Oh. So we know our P, which is 43,000. Now our R, it says the simple interest rate is 8.2%, but we need to change that into a decimal first, which is 0.082. So we plug in 0.082. And then our time. Now this is the tricky part. Our time is 15 months, but our formula needs it in years. So what we do is we change month into year. So 15 months equals 1.25 years. So we're going to plug in 1.25. And we multiply those three numbers together, and we'll find our I to equal $4,407.50. Now that's not our final answer. That's just how much interest we're going to have to pay on top of paying back our loan. So we will have to add that number to our principal. So our $43,000 plus $4,407.50. When I add that together, I end up getting $47,407.50. So my final answer will be the customer will have to pay the bank $47,407.50. And that's my final answer there. Make sure I restate the question, answer it, and prove it. Now number 9, Lenny puts $3,600 into a savings bond that pays a simple interest rate of 4.7%. So what we're doing is he's investing some money, and he's going to get paid 4.7% on top of that $3,600 that he invested. So we're trying to figure out for A, how much interest will Lenny earn in 7.5 years? So I want to write the equation. Again, it's I equals PRT. We're going to plug in what we know. So we're trying to find simple interest. That's what it's asking us right now. How much interest? So our I is the unknown. Our P is 3,600. Our rate, we have to change that into decimal, so 0.047 times 7.5, which is our T. When we multiply all that together, our I equals $1,269. Now our final answer should say Lenny will earn $1,269 in 7.5 years.